Hey guys, Wages World here. Yeah, coming at you here with a video. Um, Listen, guys, we're going to talk about the Schumann. Well, today is actually the 14th, going into the 15th, 2020, and yeah, so I'm here with you. Now we're going to go through some Schumann stuff, but also we got a cosmic ray alert going on right now, and I want to talk about that and what that actually means. Also, I'd like to talk about the CME stuff that's been going on a little bit, and Comet Atlas, how it's exiting right now. I do think that it made it past the sun. I don't think the sun ate it all the way up. And there's a lot of speculation, beyond that about that. So we'll just jump into it. So, okay, guys, we'll start here with the Schumann. Now we had another spike. Look there on the right. Now, if you take a line and you draw it right in half, both sides look very similar, especially if you stop and start them about the same time. Okay, so I want to entertain and introduce a different idea here because, I said a lot that this is probably something being done intelligently. But I want to challenge myself and anybody else out there, kind of looking at this and to kind of, make sure we're looking at all sides. And what I'm saying here is the fact that if you look at the time frames on when these spikes happen, taking consideration that we're in the summer in the northern hemisphere, we got more daytime hours, basically. Okay? And so if you look at the timestamps when these things start, it's right around 10 to 11. Okay, both of them. And they both end around 20 to 2200. Right? And I'm talking specifically of these two spikes. Now, it could apply to other ones too, about what I'm getting ready to say. So, with them happening at the same time every day and all that, we could probably pretty much at least agree that it's the same source, whatever that source is. Signatures are very similar and at the same time both days, right? So if you take into consideration that we're facing the sun, we have to entertain the idea that, every 24 hours we're facing the same spot, the sun. So is that what's causing these two particular spikes? Does something happen on the sun that's sending, whatever, changing our frequency? I think it's a legitimate thing to talk about. Does it mean a whole lot? No. What it means is that maybe we figured out a little bit that maybe that these particular two signatures came from something that was happening on the sun. That's all I'm saying here. Okay. Now, if we want to go back and look at other ones and try to figure out what's going on there, if they happen during the daytime or the nighttime, all that. But if you look here, guys, this is nighttime hours here. There's nothing going on during the nighttime hours. Now, over here, before these two spikes, yes, there was a little something, but that would be expected. We're expected to see some variation anyway, no matter what time of day it is. Now, if this continues, maybe we can kind of point towards that a little bit more. But I do think that this is a legitimate thing to talk about and to entertain, that it could be coming from the sun. Also, I also don't want people to think that, because a lot of the stuff I've been showing you, I still truly believe that it's coming from something intelligently doing something. I really do. There's really only one way to kind of, blame that on something when something happens exactly, right? Like somebody flipped a switch. First off, on these particular two spikes, it's not exact. It's like within an hour or two, both directions. So that would be kind of consistent with something coming from space. Just my opinion. So that's just something I wanted to bring to you guys and show you. That's just what I was kind of thinking right now. Okay, guys, I got you over here at NOAA, Space Weather Prediction Center. All right, this is where we go to look at the space weather conditions. Okay, so I was telling you guys, look here. If we look at the space weather overview, you got solar X-ray flux, which is basically what detects solar flares. That's one of the diagrams we look at, and you can tell it tells you what kind of flare class it was and all the above, right? Now there's a proton flux. We don't typically talk about that because that typically doesn't even move hardly ever. Just saying. Now, the geomagnetic activity, I think we need to speak about this here because this is what we're talking about with cosmic ray alerts. You see how we're in the basement for, over a day? There's basically no activity, guys. We're going on 3 days, if not longer. So whenever that happens, our geomagnetic activity level is down. more cosmic rays get in, especially through the pole areas. All right, that's what we talk about. Now, so if we go down here, we're going to check this out real quick too, because before we get into the cosmic ray thing, I got a graph I want to show you and explain to you what a cosmic ray actually is, because I get a lot of questions on that. Now, if you look at this, you can see where something changed like immediately. Something happened. If you look at the ACE data, you can draw the hardest line right about there. Okay, so let me take that line back off of there. Look at that. Okay, you're looking at very, very consistent conditions all the way to that point. Okay, now a data point on this graph is just a dot, just like on your TV. You're seeing a lot of pixels. That's where they get that name pixel. It's a pixel, basically. Okay, now, like I said, you draw a line right here, that's when something changed. Most definitely changed, and it changed very abruptly. Because you see more of a straight line, so that means all those data points were lining up real close to each other, forming a line. At least the appearance of that. You get but what we're getting now is what I call popcorn. And what that means is it's fluctuating at a bigger rate from high to low. Okay? So that's why you see that kind of a look. That's what that means when you're looking at this. But as we can tell, they all change at the same time. Solar wind speed, density, temperature. You know, orange, density, yellow, speed, and green is the temperature. That all changed all at the same time. So something happened there. But if we go over here and look, now I don't know if you guys remember, but yesterday on this graph, there was nothing up here. That's already happened. Whatever, that's 2 days behind us right there. Okay, that's historic. So it did. We had a higher dense effect going on for yesterday at some time. So whatever caused that, it could have been a coronal hole. We talked a little bit about that. But just like I said before, the density was up, but the speed was down. It's very typical. Okay, but as you can tell, they're not really showing anything big time coming in the future here. Okay, nothing's big changing. Now that could all change. We get a CME or a solar flare. Okay, just so you guys know. When they get more data in, they actually change that graph. Auroras. Okay, now we did have a spike here, but I'm not so sure that if that wasn't an error, but I don't think it was. And let me tell you why. Because that's the exact same time that, well, if this thing would unlock. My goodness. Sorry about that, guys. The stupid thing just was running real slow and real jerky. Anyway, at that time that spike had happened down there was the exact same time that it happened up here. Everything changed. So I do think something happened. I think it was most likely probably a coronal hole stream that got here, and we're now experiencing higher solar wind and all that. So, and I went and looked at the magnetosphere model, so I'm not going to take you over and show you because it does take some time to do that. But we were taking a little bit of increase in activity, just so everybody knows. Wasn't nothing crazy, okay? Now, I have to say here, too, that that's pretty low wind speed. When you get down around 280, you know, you start talking lower stuff than that, that's actually abnormally low. So that, you know, that's to be, it kind of goes along with this. Okay? So when we're talking about all this, it all ties together to, you know, that's why we have a cosmic ray alert most likely. I haven't looked or anything, but I'm just telling you, every time it's down, geomagnetic activity is down this low for that length of time, we start getting alerts on cosmic ray alerts. So, and we are seeing that. So just hold on here just for a second. Okay, guys, I'm going to tell you what a cosmic ray is, and you know, I'm going to give you a couple different definitions from a couple different sites, but they're basically saying the same thing. But let me, I'll just read this to you real quick. Cosmic radiation or cosmic rays. Now, it's important to know that that's actually, there's something different there. So, it consists of very high energy particles. Okay, these particles come from outer space, or they could come from our sun. All right. Scientists first called these particle rays because they thought they were a form of electromagnetic radiation, but they are not rays at all. They're particles. Okay, that's important to know. There's a difference there. Okay, so here's the other definition. Says, for example, during a solar flare, many particles are ejected from the sun. When these solar particles interact with the Earth's magnetic field, they tend to spiral in to the Earth's magnetic poles. Okay, I said that a lot, and that's why we talk about alerts going out to pilots and stuff that fly higher towards the poles and even higher in elevation. That matters. Okay, so why does it matter? Well, it tells you right here too that this is observed as aurora on the northern or southern lights, or the northern or southern lights. That's what they call it, right? So that it's just a good sign of all that, of us getting those kind of cosmic rays. All right. Now, when cosmic rays hit our atmosphere, they turn into pions, right? Then they go to neutrinos and muons. They split. Okay. And I'm not going to get into a bunch of detail. I've already went over this in big detail, and I will put out another in my playlist of what this actually is. But I want to give you a brief little thing here, okay? So these neutrinos, once this pion splits into these two subparticles, okay, if they make it to the surface, the muons is really what we have to worry about. That's what would make us sick and bother us. Neutrinos, they actually, obviously neutrino comes from a base word of neutral, and that's where you get that. Now, whether or not it's completely neutral, I don't really know. But I do know that these things, when they spiral in, they actually will go all the way through the Earth. And the Earth obviously will absorb some of it, but I do know that a lot of these actually make it all the way through. But for our concern, this is what we have to be concerned with. This is a muon. That can make us sick. So that was just a little rundown of how that actually happens when a cosmic ray hits our atmosphere. Now, we have to keep in mind that this is one of the main reasons it's so hard to get to Mars. Because once you get past our magnetic field, the astronauts in that equipment doesn't have the protection of our atmosphere and magnetic field. So all these particles are smacking these guys in the face, okay? And that's what they have to try to do. They're designing equipment that can deflect all this, or at least protect them from these things, in order so they don't get sick when they make it to Mars and come back. That's why it's so difficult. It has nothing to do with trying to have enough power to shoot ourselves out to Mars. Okay, it's not what it's about. It's actually about more so this than anything. So, and I'm sure there's a whole lot of other things there. I mean, obviously, we can say, hey, there's a lot of stuff that I'm not talking about here when it comes to that. But I do think that this is one of the main reasons. My guess is they could they've already done it, guys. They've sent stuff already to Mars. The rover and all that kind of stuff. So, anyway, that's why cosmic ray alerts are important, because they can make us sick. Especially those that fly higher latitudes, or even just fly at all. Prenatal passengers and all the such. So, okay, guys, this is Seeds. This is yesterday. And this is that continuing CME stuff I was showing you guys yesterday. Okay, so we'll look at today's latest one, which is right here. And you can still see that it's ejecting some. Okay, and right there at the end, it almost looked like something happened too. And we don't have any data for today yet. Right about there. Okay, is when I started seeing it. You can even actually see it kind of detects. Well, it's seeing kind of a CME at the beginning of that day. But it does look like we're still having stuff going on. And we'll have to wait and see. That could be coming at us. I'm not sure yet. But I wanted to show you that wasn't like we're not having a big explosion right now. But we still could be getting some energy. Most of that other stuff wasn't coming at us anyway. But those were still CMEs. And we needed to talk about them. Plus, Scott caught that. Now, let me show you something real quick. Okay, guys. This is something Scott was looking at yesterday. He posted this on his channel. And like I said before, guys, I was, waiting a couple days so people can go check it out over there. But he said, go ahead and use it. So I'm going to show it to you guys. This is what he caught, okay, during that CME I just showed you guys. We'll click back over this way. This is on Cactus. You can see the timestamp there on the 12th. Yeah, ignore that, please. But it's hard to sit here and say something isn't there because, I mean, it keeps showing up in the same spot during CMEs, during all that. And I just, yeah, you guys are looking at it just like I am. I'm showing it to you just how it's presented to me and just how we're seeing it. And it's amazing that this is actually happening, just to be honest. And it does look very similar to what we caught the other day. Okay? You know, and that is what it is. So, obviously, you know, you make up your guys' own mind on that, but for me, that's something we need to look at, guys. I mean, it's in your face, man. And Scott does such a great job of catching that. It's just awesome that we're here to see this kind of stuff. I mean, look at it. It's jaw dropping, to be honest. Okay, and I can tell you, like this particular capture, like right there, that looks like maybe he had a little contrast, but not much is being done to that. If you guys go over to Cactus and look at this for yourself, it's going to be almost no filter, and you're going to see it. Okay, it's going to be there without no filter. You're going to see it without a filter. It might not be that pronounced, but you definitely will see it. So I just wanted to show you that real quick. Also, it's of note, you see you see something shooting by there. I just thought that was kind of cool. It's probably a little meteorite or something. Nothing big, but it's cool. Okay, but for those of you guys that missed yesterday's video, this is the direction of where that CME did blow off. That was actually the second part of that CME. The first part blew off. It was even bigger than that. But it was not coming earth facing, okay? It wasn't coming earth direction. Sorry about that, guys. If you look at this, here's the earth, right? Also, this is Parker SP, that green box right there. That's what that satellite is. A few days before that, that thing barely missed getting smacked with that big CME that happened. Okay? I mean, it barely missed it. And it may have even been, it probably caught a lot of the stuff that we were seeing there. Now, me and Scott's been talking about this for a long time. How it seems as though a lot of times when those bigger things are happening, that Parker SP satellite is very close by. And, you know, it makes sense that it's closer to the sun anyway, but for it to, like, do its little whip around the sun and get faster, like it does when it kisses the sun pretty much, it seems as though it's always happening during one of those CMEs and when we're catching our object. It's like they're doing that on purpose is what I'm saying. Now, whether or not that's the case or not, you know, obviously I can't give you 100% on that, but it most definitely seems that way. And, you know, that's something that Scott had mentioned early on during all this, but, you know, I'm seeing it with observation here, so it's kind of confirming what we're thinking there. So, okay, guys, I got you over here. This is Sechi. This is on stereo A. Okay, it's the side view of the sun. For those of you guys that don't know, the sun's here. Okay. Now, Sechi's sight actually went down like over a year ago. We're not going to get it back, guys. I've just been like whatever with that. But with this sight here, we can actually still, because that was actually through the Navy. That was a naval site, and for whatever reason, they're not letting us have it back. We can discuss that later, but it most certainly, we're not getting nothing from it ever again, probably. Now, you're seeing some flashing and stuff there, and what that is those are some of those CMEs blowing off. Now, this is multiple days here, okay? Look at the timestamp. You know, I started it on the 2nd, but I'm not sure if it went back that far or not. It may not have. How many we got 280 captures here. Let's let it reset here and see where we got back to. But, yeah, on the 2nd. So what I'm showing you guys here is Comet Atlas, okay? I'm going to show you guys how it did not go into the sun. Okay, it made it past. Typically, when we see these comets, they'll kind of either, if they're coming from this direction, you'll see them kind of get right there and they kind of dive in. All right. Or if they're coming from the other direction, obviously it would look opposite of that. Right. So it depends on if they're coming towards this satellite or away. But this one actually was kind of, looks like it might have been coming in from the side. So what we're going to look at here, back on the second when it started, I could take you way back if I wanted to. Actually, you could see it come from all the way up here and travel all the way across the screen. Okay, that was Comet Atlas. Now listen, again, I don't think it ate it up, but we're gonna take a look at this thing as it's exiting, and that's what I'm trying to show you here. So actually, I think I'm gonna speed this up because you probably see it better the faster it's running. Yeah, okay, yeah, that's better. Now you guys probably seen that thing right away. I'll point it out. Well, it's right there right now, but we'll watch it a few times here, run through. Again, I just thought it was neat, and because it was a lot of the subject for a good while here. Okay, but yeah, hold on a second. Let me pause this. Okay, sorry about that, guys. I just wanted to cut down some of the days there because it was running like days after the thing was gone. Okay, so what you're looking at is right in here. You see that? You see the comet right there? Okay, that's Comet Atlas. We'll zoom into it. Right now, again, I have to point out, it's well south of the sun there. So it is most definitely passing the sun. It's not going into the sun. At least it doesn't look to. Now, whether it does something funky from here on out, I can't say. But, if you look at that, it most definitely looks like it might be exiting. And we'll never see it again, guys. We won't be alive if it makes it back through again. I guess the solar wind could eat it up from behind. I don't know. But it did break up into a bunch of different pieces. But whatever it did from there, again, I'm not completely clear on. But as you can see, this thing is leaving. So anyway, guys, I'll come back at you with another video tomorrow probably. So God bless. Yeshua saves. And yeah, you can drink this Kool-Aid.